Okay, this is Mr. J, and this is balancing chemical equations. What we want to do also is label each one as a synthesis, decomposition, double replacement, single replacement, or combustion reaction. Um, we're going to start with the first one. Now, when balancing, there's no real secret to balancing, except if you have a personal preference, like how you want to start balancing your equations, then go with it. Always make sure you have a good eraser in hand because you're going to be erasing quite a bit unless you've been doing this for a while. When I look at the equation, first of all, I do notice that this is a synthesis reaction, so I'm going to label this as synthesis. And we have two compounds on the reactant side, forming one compound on the right side. Actually, two elements over here, diatomic. Anyway, what we have here, I look and I see that the hydrogens on each side of our equation are not balanced. Now I like to start with the larger molecules first. I'm going to start with the NH3 on the right side. Notice I have three hydrogens there, and I only have two hydrogens on this side over here. It's that crazy 3 and 2 rule. 3 and 2 can't go into anything but 6 is the lowest common factor. And so what I want to do is I'm going to put a 2 right in front of that um, NH3. And what I have is I've made 6 hydrogens. I'm going to put that number 6 above that. And I still have, if I look at my left side, I've got 2 hydrogens on the left. And I can make that 6 by putting a 3 in front of that one, and now I have 6 of those. I also have solved the problem of my nitrogens. I have 2 nitrogen atoms over here, and I've got 2 nitrogen atoms over here, and so that is now a balanced equation. Okay. Looking at number 2, I have a decomposition reaction. We have a compound breaking down to its respective components. I notice that I have that crazy 3 and 2 rule again with my oxygens. And so I think what I'm going to do is go on to my left side, my reactant side, and put a 2 in front of my potassium chlorate. And then I'm going to put another 2 over here to solve that for that potassium. What it does actually is I have 2 potassiums here, and I've got 2 sitting right here. I've got 2 chlorines here, and I've got 2 more chlorines here. I've got a total of 6 oxygens over here. I only have 2 on this side here. Well, if I add a 3 in front, that gives me 2. That gives me 6 total for that one, and so now that one is also balanced. Okay. I want to go to a little more complicated one, and let's go to number 5 right here. And so when I look at number 5 and let's kind of scan through to see what's not really matching up as far as balancing the number of atoms on both sides, I notice that over here I've got an NO3, but I've got 2 of those NO3s. And on the left side, on the reactant side, I only got 1 of those. So I think what I'm going to do on the left side, the reactant side, is put a 2 in front of that. And what that does is it gives me a total of 6 NO3s over, or a total of 2 NO3s, excuse me, right there. And that gives me 2 silvers right there. Okay. In order to fix that silver on the right side, I got to go ahead and put a 2 in front of that one. Okay. And what that does now, if I go through all of this, I find out that my silvers are balanced. I see my nitrates are balanced. I see that my chlorines are balanced. And my magnesiums are also balanced. Okay. And this would be called a double replacement reaction. Okay. You can see that those cations have swapped places, and that's what that double replacement reaction does. You look at the NO3, it's paired up with the silver on this side, and it's now paired with the magnesium on this side, where the chlorine was paired up with the magnesium on the reactant side. The chlorine is now paired up with the silver on the product side. So there you go. That's how you can determine the product side of the double replacement reaction. And here, if you notice, quite honestly, we have a hydrocarbon right here, number 7. And we have oxygen also. as reactants, and our products are carbon dioxide and water, and that's always indicative of a combustion reaction. Okay. If you have any other questions, just go ahead and get a hold of me. Good luck.